Hi fellas, this is Chemaddicts again with the solution. Welcome back to our another video tutorial. Well fellas, previous week, well fellas, well fellas, today we're gonna solve the previous question. Okay, so we're gonna proceed to the previous question that we were doing. So if you have missed fellas, if you missed the previous question, okay, so don't worry, don't need to worry. I'll I'll put the link at the end of this tutorial. Okay, so enjoy. So previously we have learned about scaling. Okay, so how to scale this peculiar data. Okay, since they are really small. So we learned about scaling in the previous tutorial, and we also learned about how to deal with small significant figures. Okay, so fellas, today we're gonna finally plot the graph. So let us plot this graph. Okay. So at first, let us read this question. Read the following question. So the question says. So the question says, plot a graph of ln k against 1 by t. Calculate the gradient of your graph and use this to calculate the activation energy. EA. The Arrhenius equation can be expressed as blah, 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 blah. Okay. So the total mark for this is 5 marks. Okay. So let us break this whole question into small parts. Okay. So first they have asked us to plot the graph of ln k against 1 by t. That's totally fine. And secondly, they have asked us to calculate the gradient. Okay, the gradient of the graph that we will plot. And thirdly, they have asked us to calculate the activation energy. Okay, so as you can as we can see as you can see as you can see that this question has three parts. Okay, so uh, well uh, well, we can say that this will have 2 marks and this will have 3 marks. Since calculating gradient and calculating using this equation is involved, so the calculation would carry 3 marks and plotting would just carry 2 marks. Okay, so total we have 5 marks. Okay, so now at first let us plot the graph. Yeah, finally we're gonna plot this graph. So now plotting the graph. Okay, so now we want to plot the graph. So here are the informations given. So in temperature time graph, sorry, this should be uh, okay. Before plotting the graph, let us at first examine this equation given over here, the Arrhenius equation. This is the famous Arrhenius equation. Okay, so as you can see, this can be written as something else, that is the equation for the straight line. Okay, so the equation for the straight line is y is equals to mx plus c. You all know, fellas, the equation for the straight line. Okay, so it's pretty easy. So if we compare this Arrhenius equation with this straight line, we will get that ln k. Now we are comparing this and this. Okay, so in here y should be the ln k, y is the ln k, and here m is minus e by r. This whole value is value, this whole value is m, this whole sorry fellas, this whole value, sorry with my accent. Okay, sorry for my accent. So here this whole value, this one minus ea by r is uh, gradient, and here 1 by t is x, this is x man, okay, and this is constant. We are not concerned about the constant over here, okay. So we can summarize this thing. Y is ln k m, which is the gradient, is minus EA activation energy divided by mole, what is it is called molar constant, okay. So in here this is in here this is 1 by t. So x should be the reciprocal of 1 by t, which is temperature, okay. So we have three things over here. One is y, and one is x, and another one is m, which is gradient. This is gradient, we all know gradient, okay. So here we need to draw the graph y against x-axis, which is ln k against 1 by t. So we're gonna plot this thing y x. Here this is ln k, and in here x is 1 by t, okay. That's totally fine. So now, as now we have came to know about this Arrhenius equation, this peculiar equation, and now we're gonna draw this peculiar graph, okay. So as you can see that this corresponds to this equation, so this should be unconditionally, definitely a straight line, okay. So here let us look at the graph. So now let us plot the graph over here. So if we plot, we will get something like this, okay. So now we are going to plot the graph one by one. So the first first point is 3.41 into 10 to the power minus 3, and this is x, okay. Let us write, this is x and this is y, okay? So this first point is 3.41 into 10 to the power minus 3, okay. So as you can see in this value, that here all these things are 10 to the power minus 3. So this, since 10 to the power minus 3 is in common with all this value, so we can completely ignore this value, okay. Ignore this thing. So let us plot, sorry, so let us plot. So this is the first point. uh, so our first point is 3.41. Sorry, I have made a mistake. Sorry about that. Really sorry about that. So our first point is 3.41 into 10 to the power minus 3 on y-axis, and minus 9.75 on the, sorry, 3.41 into 10 to the power minus 3 in x-axis, and minus 9.75 on the y-axis. Okay, so let's see. So this is the one, uh, 3.41 and 9.75. So this is how we gonna plot. So in here, since this is 3.40, so as we can see that on x-axis the smallest division is 0.01, okay. So unconditionally we can say that this is 3.41, this particular point, okay. This particular point over here is 3.41. Once again I'm repeating that we all gonna ignore this 10 to the power minus 3, okay, since this is common in all aspects, in all the data. Okay, this is common in all data, so that's why we are ignoring it completely. So in here this is 3.41, and here this is 9.75. So this is 9.75, so we have got this. Well, let us move on to the next point, which is 3.30 into 10 to the power minus 10 to the power minus 3. Why am I repeating this 10 to the power minus 3? We should ignore that. Okay, 3.30. Our next point on x-axis is 3.30. Okay, so at first let us find for 3.30. So since this is 3.20 over here, so this is 3.40. So in the middle it should have 3.30. So this is the thing. So mm, so this should be 3.30, and in here 3.30 minus 8 point, this should be negative, minus 8.70. Okay, minus 8.70. So this particular point is 3.30 in minus 8.70. So in here on the y-axis, sorry to mention about that, the scaling on the y-axis is 0.1. So easily we can say that each uh, this here, this point is uh, 8.70. So this is how we're gonna plot the points. So let us move on to the next point, upper one. So the next point is, we have dealt with 3.30 minus 8.70. Now we're gonna deal with okay, it's here. Okay, by the way, don't take it otherwise, sorry. So in here this is 3.19 and minus 7.50. Okay, so let us check. Since this one is 3.20, so here one box behind will be, one box behind would be, should be 3.19. Okay, so let us let me tell you one thing. Okay, that we are ignoring this 10 to the power minus 3. That's totally fine. For the calculation we are ignoring, for plotting purpose we are ignoring this whole bunch of things. But while naming the axis, we must consider this thing on the, while writing the name of the axis. Okay, so while writing the points over here, when we write these things up over here, we should write like this. Okay, so we shouldn't, at that time we shouldn't ignore this thing. But for the calculation purpose, for plotting purpose, we can ignore this whole thing over here. Okay, so let me tell you one thing once again, that for calculation purpose we may ignore this for a while. Okay, so that is the thing I want to say to you. Okay, so here we are just plotting, so that's why we are to make it convenient, so we are ignoring that thing, that peculiar thing. Okay, so now let us move on to the next point. Okay, so the next point is 3.10 and 6 minus 6.60. Okay, so here is the, this is point 0.5 and here it is 6.60. so this is on the y-axis, and let us check out on the x-axis. So on the x-axis this is 3.10. so since this is 3.20 and this should be 3.10, So here we have this point over here. So this is how we gonna plot this peculiar graph. I know fellas that you have plot plenty of graphs, but for this particular graph you might find it difficult since these values are really peculiar. So that's why. Okay, so that's why I'm telling you in details. Okay, so we are doing it in details. So now let us move on to the next point. So the next point is 3.00 into 10 to the power minus 3. Again, I'm involving here this thing. Sorry for that, fellas. So this is 3.00 here minus 5.60. So this is minus 5.60. So this is minus 5.6. This point is minus 5.6, and this is how we're gonna plot. After plotting, so after we have plot these points over here, we need to draw the straight line. Since this whole equation, this Arrhenius equation, corresponds to the straight line equation, that is y is equals to mx plus c, that we have discussed earlier. This thing, since this corresponds to this, so it should be a straight line. Okay, so it should be a straight line. So here is one thing that is required to mention, that it should be the best fitted line. Okay, it should be the best fitted line. Best fitted line. So this should be the best fitted line. So as you can see that the student makes one particular mistake is here, that here uh, he have miss out the point. Okay, this point. So this is not minus 9.7. So if you have noticed that he have missed this point, this this point is not minus 9.75, this is minus 9.9, as you can see. So you may round this up and you can write this as minus 9.8. So this should be one box ahead. Okay, so in here, so be careful about that. Okay, so we must be careful while plotting this graph. So if we plot this graph, the straight line shouldn't be dark line. Okay, so overwrite it. We shouldn't overwrite this straight line, overwriting in the drawing. Okay, so as you can see that this straight line is not sharp, this is bold. Okay, so this is bold, so this might be rejected by the examiner. So we should consider doing this in a sharp line. Okay, so this should be a sharp line, not bold line. So you must attempt first. Okay, so you must attempt in the first place. Okay, so the straight line isn't the sharp. Okay, the straight line should be sharp. Straight line should be sharp. Okay, the straight line is not sharp enough. So since the straight line is not sharp, so the straight line is not precise, so the graph is not precise. So for this you may lose 1 mark. So out of 2 you will gain 1 mark. Okay, so in here you have seen that the total mark for plotting is 2. So out of 2 you will gain 1 mark for messing this up. Okay, so I hope that fellas you have understood the plotting. Okay, how to plot this peculiar graph. Okay, so in the next tutorial we're gonna solve the activation energy. We're gonna find the gradient of the graph. Okay, which is activation, and we're gonna find the gradient of the graph and use it to find the activation energy. Okay, so in the next tutorial we're gonna learn how to find the gradient and how to find the activation energy. Okay, so fellas, it's it's been a quite lengthy video, so we're gonna see you again. I'm gonna see you again in the next video tutorial. So stay awesome, best of luck, peace with chemistry.